Most sets of points do not lie in a vertical or horizontal line. As we can see in this example, we have 2 points and they're diagonal from each other. Counting the units between these 2 points is impossible, so mathematicians have developed a formula using the Pythagorean theorem to find the distance between 2 points. So let's look at the Pythagorean theorem and how it applies. We can take those 2 points that are given and we can draw the right triangle around these 2 points. We can go horizontally and vertically from the 2 points and have them meet at a third point. We can then use the Pythagorean theorem to find this distance in red because now this is the hypotenuse of this right triangle that is created. So we can count now the horizontal and vertical distance of A and B, the legs of our triangle. So we have that A here is 3 units and B here is 4 units. So we can use that in the Pythagorean theorem to solve for that hypotenuse, that value of C, because that's the distance now between the 2 points. So we would have C squared equals A squared plus B squared. We now know A is 3 and B is 4. So C squared equals 3 squared plus 4 squared. If we square 3 and 4, that gives us that C squared is equal to 9 plus 16. And 9 plus 16 has a sum of 25. Then taking the square root of both sides, we end up with that C equals 5. And this matches if we recognize that this was going to be a Pythagorean triple of a 3, 4, 5 right triangle. But now because of that, we know the distance between the 2 points of 2, 2, and 5, 6, those 2 points originally in the example is 5 units. We couldn't count that ourselves on the graph, but using the fact that it was the hypotenuse of this right triangle, we know it has a length or distance of 5. Here's another example. Let's try to find the distance between these 2 points. Again, they're not horizontal or vertical to each other, so we're going to have to create a right triangle and use the Pythagorean theorem to find the distance, to find the length of this new hypotenuse. So if we come directly down from the first point and then we move left to the other point horizontal to it, we're creating that right triangle with side lengths of A and B. And now the distance between the 2 points is the hypotenuse. So if we use the Pythagorean theorem, C squared equals A squared plus B squared, we can count that vertical side of A, where that equals 3, and we can count the horizontal side where B equals 6, and we can now substitute those values into the Pythagorean theorem. We have C squared equals A squared plus B squared. Making our substitution, we now have C squared equals 3 squared plus 6 squared. Squaring our numbers, we have that C squared equals 9 plus 36, and 9 plus 36 is 45. Taking the square root of both sides, that gives us that C is approximately 6.7. That's where we're rounding the square root of 45, that value to the nearest tenth. So if that's the value of the hypotenuse of this right triangle, that is also the distance between the 2 points. So we have the distance between negative 3, 8 and negative 9, 5. Those coordinates is approximately 6.7 units. And again, we couldn't just count that. We had to use the Pythagorean theorem and this right triangle that we formed to help us. Let's look at one more example. Here we have these 2 points that we're trying to find the distance between. And because they're not horizontal or vertical, we'll have to use the Pythagorean theorem and a right triangle to help us. So here we've created our right triangles with now a side length of A and B, the 2 legs, and we're solving for the hypotenuse of C. So we can count the units of A since that is vertical and A equals 9. And we can count the length of B since that's horizontal, so that if we count up all those units on the graph has a length of 12. So if A equals 9 and B equals 12, C squared equals A squared plus B squared will turn into C squared equals 9 squared plus 12 squared. Then 9 squared is 81 and 12 squared is 144. The sum of 81 plus 144 is 225. Taking the square root of both sides gives us that side length is equal to 15. So the hypotenuse is equal to 15, the hypotenuse of the triangle, and that's representing the direct distance between the 2 points of -5, 5, and 7, -4. So if the hypotenuse of the triangle is 15, that is then the distance between the 2 points. It's 15 units.